mic is
I don't know. How many of you are familiar with Octane, what it does? And, all right. Half that I didn't. And how many of you are familiar with the concept of light fields and its optimization? Okay, good. So this, this workshop is really meant to sort of introduce a lot of these concepts that we're applying towards the content creation pipeline in VR. If you guys, how many of you have tried Gear VR or own Gear VR? And how many of you have seen the metaverse contest with the Oculus and tried out images on there? Any of you guys created any content? Oh, one of you. All right, excellent. So the tools that we've been focusing on for the future of VR have been really focusing on one of the rendering synthetic content. It's a pretty simple problem in the sense that once you can render a scene as beautiful and real, like this one here, and this is all created in Octane. This is actually one of our sample scenes that we did released last year. Creating a virtual version is straightforward.
I have some.
Out of your VR, you can actually check out one frame of this video rendered as a stereo format. This is the format that John initially came up with that allows basically the Gear VR to represent a render, a render with the highest possible fidelity. And more recently, we've been working on getting that very same format to be animated at 160 hertz, but 120, thinking about future VR devices where that'll probably be more. And so we've actually been moving Octane to a renderer that's working on a single laptop where you can do this stuff you render on one machine to the cloud where it's entirely run on servers. And it's connected to your app, Maya, or Photoshop, or Unity, and it generates these things on the fly. So on the other side of the equation, we need to figure out how to capture things from the real world, especially performances of people, which are challenging to create procedurally on the computer, but probably some combination of the two is going to be the future of content creation. Just as we sort of see today when we're doing a high-end film in CG, you're doing a lot of virtual sets and you're doing a lot of CG characters, and that's of course where a lot of the capture comes in around the world with light stage and light filters in general. So we think that there's a case we made with the holodeck type of experience that everyone's sort of waiting for is coming. And I think that it really is thanks to VR and AR that you're going to see something like this happen much sooner than normal. I mean, we don't have to wait for the holodeck to be built to have probably an experience of being better. And I go back to the idea that when you're looking at the Star Trek Next Generation version of the holodeck, everyone had to sort of dress up and Sherlock Holmes to go and have that experience. Whereas in VR, your avatar, your body can be anything you want it to be. And you're talking about devices that could be given to millions of people on cell phones. You see that embodied today in the Gear VR measurements. I think that everybody invested in this ecosystem is interested in seeing that those devices also work great, like the earphone situation with your phone. And that is definitely, where people talk about a billion VR devices in the coming years. That's, I think, where that's going to happen. And so our goal with Lightfield rendering is to figure out a way to get the highest quality rendering to work and achieve low optimize. And it isn't by going through the traditional rendering pipeline, that's what you see today with Unreal and Unity, although those very well may happen. And you just get a tweet from Carmen talking about how it's, Moore's Law's coming to an end, and it's going to be very hard to get the capabilities of the type of X running on a mobile device. And I agree that even if that does happen, it's going to be a while before they can start building people. So the concept of light fields is to sort of deep complexity of the simplicity of a video feed actually have the benefits of the holographic volume where you can move the piece through the scene at really almost no cost. And so for capture content, in fact, I'll talk about this here with us in the audience, we've been sort of looking at what kind of camera maker range we need to capture a scene from almost every possible angle and generate a light field, which really is sort of a panoptic representation of the scene from every possible view. And of course, we've been working at compressing that. And so, Paul sort of first adapting as a video version. This was to sort of have some big adapters about the gigapixel per frame with many of these sort of arrangement. And we kind of put that into practice with this static version, which actually took just one camera and basically rotated in a circle. Let's skip to that slide. So there's a lot of work that's been done around sort of reflective slow capture and sort of how they get turned into data sets. There's obviously object capture, which is something that you see puts a great benefit for artifacts and objects that are very important to the president. And there's Paul, the photos, which was scanned in with how many days do you think it took? Like 3 days? stage. So it's pretty cool. I mean, light fields in general, if you take this individual eight-dimensional light field versions, not just every viewport, but also all the different lens divisions that you need to do a really nice holographic representation of an object. You can relate it with different viewpoints. And there's also work that's been done around the material properties, which is important for industrial design. And we've even played around with doing that with collectibles. Like you see here, this is a test with a very simple iteration of light field captured not just the viewpoints, but also the surface properties using just three lengths, not hundreds we normally be using for very high-end reflective field capture. And so getting back to what I was describing before about how we could go about creating a very inexpensive mechanism of capturing light fields and volumetric content, this was a device that all the breakdown that we come up with, which is a single DLSR, the second one is just a counter rotate, spins it around, and you can change the speed of that rotation from having to take a few hours if you see it really still to essentially doing it in a matter of 10 minutes with this video, using the video, but it essentially captures thousands of these frames, and that can be stitched together and turned into a sphere you can actually walk through, and it gives you perfect parallax, perfect viewpoint navigation through that volume. And it's really impressive. I mean, this is the very first iteration of running at we actually had, in one night sort of really turned that into an octagon versus a sphere. The newer version that we have now, which we just published last week, is really a beautifully rendered sphere that you can now try and have work in the vibe with CV1. It looks beautiful. And to me, it's the future of images. Everything that you guys have seen is rendered metaverse, one of here we are now. Imagine that quality of being able to move through that. And of course, the next step is being able to add control frames for that, so you can actually have videos playing back. There's no reason why the same system for static would be extended to video, which comes at a greater cost. I think from our perspective, you're going to see smaller versions of the full sphere applied to video, and then of course for synthetic content, you can render light fields in any size and any volume. It's also important to note that these can be stitched together. There's going to be stitched multiple viewpoints to create a 360 video. You can take different nodes or positions of the scene and stitch those together in our light field viewer, and just have infinitely large scenes that can be streamed in. And remember, light field rendering is very cheap. So rendering these light fields, no matter what the complexity, on a type X, which is what we were showing in SIGGRAPH on the vibe one, it basically renders these light fields in 2,000 frames a second. So there's a lot of room to do some interesting things on that. It also means we can be rendering this on mobile devices pretty easily. We can also look at trying to get studio content in this format. We work with Warner Brothers, also William Morris Endeavor, which was part of IMG, to work on scanning sporting events and broadcasts. And we did some really interesting tests with the NHL. And this, by the way, is a light stage capture of Clay, one of our engineers and CEO of the company, actually. And he sort of posted this test. And it's really the idea that when you're building an experience that includes not just 360 video, but volumetric light fields, think about motion graphics, think about being able to represent the players procedurally. So doing a scan of all the players' heads is actually something that we think is going to be a necessity. Just to have sort of an image of a player on the motion graphics. Today on live broadcast, we imagine that being extended into light fields or reflective fields with this process. So we can build a portable version of the light stage to be brought to a mass for this kind of purpose. Going back to more synthetic style content, we want to be able to deliver a pipeline for any sort of tool of your choice. We support 24 tools right now through Octane plugins, and be able to render these beautiful pieces of content. And if you want to stick around, we have some 18K videos that we rendered for some of our partners that look just phenomenal. And this is on the Gear VR. It's a relatively new experiment that we've been doing just to see what this metaverse and kind of content, and it's very conventional like emotions, but it's very compelling. What's interesting is we've also seen a lot of people try to figure out how to get cube map videos for real world content. And I don't think that's going to happen through traditional 360 video capture. I think you need to build a light field of either the scene in motion or is it still a static environment, and then you can render that in Octane as a stereo cube map video very quickly, of course. And I think that's what we're going to be experimenting with now that we actually have light fields that we can capture in the world with this high quality. And then from a perspective of just designing experiences that you can really navigate and walk through, I think that what we learned was putting together some of these very first scale of the world, almost putting the world on the stick, so that you can really look at it from any angle and look at it and walk through it. And I think that is, in some ways, a very compelling and important element that people I don't think about because they haven't tried experimented with this kind of quality and speed, being able to be mixed and matched with your control of the device. And I think that the idea of walking around the VR scene is great, almost like for a minute or two. But I think a lot of people are just going to want to have the ability to almost pull the world around them. I think that's sort of what I found recently that I control working. And that becomes even more necessary with these giant environments that we're sort of building and experimenting with, where even with a 2-meter, 3-meter walking area, you're just not going to walk through the Death Star. You want to have controls and allow you to sort of push and pull the world, scale it, teleport, or whatever. So I think that there's a lot of creativity that can be applied to the navigation and experiencing of scenes and stories in cinema. And I think that certainly walking at one-to-one scale is one option, but probably is not going to be more than 10% of the use cases, in my opinion, going forward. As far as what we're sort of planning to support going into next year, obviously there's sort of a lot of different devices that are going to be in the market in the first quarter next year, starting with CV1, Morpheus, and the Vive, and then we expect all of them, even those should focus on enterprise, to be coming along as well next year. And they're all very different. I mean, AR, VR, PC VR, console VR. There's a lot of different layers of it. Even we found as we've been trying to support nuclear VR correctly, there's actually 4 iterations. There's Android 4, Android 5, the S6, and the Note 4, and they actually all have very different capabilities in terms of just the kinds of things they can do and not support. So there is sort of this issue of fragmentation, not just in device profiles, but with the consideration that some of these VR experiences will have position tracking, others won't, some will have controller, others will not. There might be mix and match of these. And I think that we're trying to figure out what the best way to sort of package content that's created by our customers and our partners in a way that sort of works across all of these things. And it becomes a little bit like a video problem where you have different formats, you have different capabilities, and you end up just creating many different versions of the video, 720p, HD, 4K, 4K with HDR, and so on and so forth. So the platform that we're building, at lot of these when we're rendering these light fields and packaging and compressing them, will also sort of entertain the notion of actually building versions for each of these device profiles on the fly. So currently, as we're rendering these 18K maps, we're also working on actual versions of compressed iterations of these that actually have different outputs for even the current peer VR. So also working on things like Morpheus and Vive and C1. And when you request that content from URL or download it or publish it to the store, it'll basically throw it on. There's also the idea that we can stream this content, and there'll be no download or caching necessary. And that's something that requires an internet connection. Probably 25 megabit stream will be enough for you to enable render light field. For those that haven't seen anything with our light field work, I'll start with a primer from the Best Guide when we first started showing light field work last year at SIGGRAPH. And it's a good introduction to the technology for those that have never seen it or never really seen how it applies to our content. So I'll play that next. And there's no idea. In some ways, that's all right. Because half that is me discussing the I think that well, I mean, the idea that there's actually some light demos that I have in this one of the things that we've been figuring out is the way to get people to certain parts of the data in this ecosystem early on. And we had the benefit of John Carmack's deep interest in everything we're doing with light fields, and especially how we apply in a way that would sort of reward people that are entering the space early. So we did a contest with Oculus called Better Than Ever. Some of you obviously familiar with that. One of you participated in it, and it's been amazing. We had 300 entries in 3 months, which is just phenomenal. And it was very successful. We gave away our tools for free, and we'll probably do that again as we try to get another iteration of this concept up and running. The content creation was spectacular, and it showed that there really is a steep learning curve for getting artists that have been working with traditional rendering tools, or even something that only been playing around with Composer or Blender, really getting this up and running. And one of the winning entries from last month was this scene, and I thought it was fantastic. Remember, one of them is that yes, there's a lot of creativity that went but it also was a scene that was taken from a real world scene in Japan. And this is the render, and the render is obviously beautiful, and these are just stills that were generated from that scene once it was not made. And if you just load up downloads from 60 photos, I think you can check this out in VR. We also have rendered this as a light field, so we showed that SIGGRAPH, and the light field version of it. We're getting light field rendering efficient to the point where it takes less time to render a cubic meter of the scene than it did to render that 18 square cubic. Part of that is because you're already generating all the rays from the light in the scene once to render one image. So just flying that over a light field does not that much more work. It sort of plays to the benefits of how Optic works as an unbiased renderer, and it's very fast on the GPU, and having a lot of GPUs in the cloud makes this problem for embarrassingly easy to scale and inexpensive. This is pretty interesting. This sort of shows the concentration process behind that scene, and some of this is based on photographs of the real world, and then sort of the artist decided to take references to the leaves and trees and this sort of synthetically build up an environment that I think if you were to take light field capture of the scene might not actually have the same level of detail and quality. It would require so much work in the sense that you're probably missing pretty conclusions. And so I think there's a case to be made for just sampling the environment enough to the point where you can have an artist rebuild it with this kind of quality. Because ultimately we're going to want to get to the point where you can take that scene and look at it from any perspective and not be limited to what a camera can capture. And I think that's the method of essentially translating things from the real world into a synthetic representation. And this shows that even one person on their spare time on the weekends can do that. And I think there's a case in the future to be made where deep learning can actually be taking samples. I mean, if you have an algorithm that knows every possible tree and fauna and leaf, and just to sort of look around the human as well, this is sort of the pattern of splatting of pebbles and leaves. These are sort of the key markers of features in the scene. You can imagine that there could be an algorithm that sort of generates these for you. And if you remember that top video at the very beginning, well, that was using the multi-stammer, which is one of the tools that our engineers should be able to announce that spots out vegetation and goes along those lines for you. There's also an interesting use case that we sort of been experimenting with, creating truly cinematic content at the very highest end in terms of original content in VR. And one of my close partners is a studio in Barcelona, super talented, one of my JJ Longo, who was years. He created a short film, and Floyd is now being rendered for VR. These are some of the shots that we're doing in Optic VR. You can also check out some of these scenes rendered as 18K square. You can have some of the Oculus photos out. So we've been experimenting with trying to into straight up light field renders where you can all this video that was designed actually started working on this before we had a lot of these tools. It's now this immersive experience, and it's really an interesting use case where artists can be really creative in sort of pushing the boundaries with rendering and content, and sort of figuring out narrative cinematically for this stuff. And it's definitely been a learning experience for us as we've been figuring out how this works. Here are some of the shots. You can actually try this out in video and see the 2D video version of this. But there are actually shots from this great trailer that are now rendered in light field form and in script form. And I think it's really a use case for doing A/B tests or C testing. These videos to ETK to light fields. And there's just a lot of beautiful imagery that anyone experiences. It's good paint shots that are designed for a great hours of view, and you can see all these things. Like this is one of the shots that we have in here we are. And we also taken the diversity of scene right now as a light field. So the next slide actually shows what a light field looks like. This is one of those frames. And you can see it's like a hologram. It's a window into this scene. No matter where you're looking at, in this one texture, you have every viewpoint represented. And these images per frame are just a few megabytes. So it's actually smaller than the JPEG or PNG. And inside of that light field, you not only get every possible viewpoint, you get depth information so you can reconstruct the scene as a geometry condition. And you also have HDR lighting, and even all you can take into spherical harmonics and make the scene certain lines of those are familiar, just basically encoding all the possible lighting contributions around an object that allow you to be lighted. That's basically what was used in Avatar and the word in the render that we'll put later. Larger light fields becoming even more interesting is giant video screens that are essentially windows. This was one of the scenes that is also on the front VR app and on the Apple 360 apps. It's Carmen's favorite. But then you can see it in the light field, we just have the ability to look at it from any possible perspective. And it's really amazing to be able to sort of really makes a big difference in generating simple stereo content. At the end of the day, you can change the IP after the fact. You can actually change the camera view after the fact without giving up any of the quality of the render. And traditional light fields really require huge amounts of different viewpoints. So we've been basically optimizing this to the point where we've gotten it down. It's not only compressing it with traditional light field down by 1000 to 2000x, but also rendering a lot of less data. And with Octane 3, we're really going to make that difference between 8 times what it is now in 10x. And that will make light field rendering almost, a no-brainer. Every render that you do in Octane, I think, will just end up being a light field render, and you'll have this effect of being able to project that and relight it after the fact. And I think that's going to become an absolute requirement as people start targeting or want to target VR for every piece of content. I also figured it's worth sort of going over what tools we're building on this render set. Oh, thank you. Are you guys able to hear me okay by now? Okay, so it's more for the. So with Octane 3, which we've announced and is actually on our, you can hear me now, great. It's also on our website. So if you go to otoy.com and you click on Octane 3 demo, you can try out this tool in the browser. We've been adding a lot of tools to our rendering technology to handle things that have been traditionally tough to do on GPUs at the speed that we've been doing it in Octane. So one of those has been rendering volumes and fire and smoke. That is now handled implicitly in Octane. That's also going to allow us to just take in any sort of volumetric information, including a light field render, and recompose that in the scene. So when you consider that there's now plugins for Nuke and After Effects and even Photoshop that I'll be showing, that's sort of how we imagine just traditional video editing being done in the future. You render the light fields, and that could be from a real-world capture, and then you can compose a light field volume with traditional rendering tools or traditional video tools that we have plugins for. A lot of these have been shown already. We announced Octane 3 at GTC, and we're about to have our first alpha release in the next month in users' hands. And again, for those that are interested, you could just try it out on our website now, and that's sort of the pre-alpha version. But there's a lot of beautiful things that you can do in Octane that are very hard to photograph, and that includes doing really fine-grained granular structures, and of course clouds and other things, and just changing the scale of the world in a way that can't be done with, or is very hard to do with traditional photography, and that becomes a lot harder when you're also trying to capture light fields. In terms of generating a lot of these volumetric, things like smoke and fire, we support OpenVDB. That is now built into Octane, and that means that any tool that supports that, which is many of the physics and volume tools in the industry, can now just be, you can just import that into Octane. We're also adding something that I think is incredibly powerful. Any of you guys are working, with tools in the past that have used, custom shaders and BRDFs. Well, now Octane can support that with OSL. And we're essentially building a compiler, GPU compiler for that into both Brigade and Octane. Brigade is our real-time render. That's going to be used for games on the cloud for VR. Octane is more for offline rendering and processing of those data sets. And then we're also looking at supporting things like PTEX and other elements. And then there's also a media format that we're building around the output of Octane, and that is already embodied a little bit in what you see with these 18K stereo cube maps. We have a custom codec that encodes that really nicely. We haven't put that out on the Gear VR, but we will. And that very same codec is also what we've been using to store light fields. So when we showed our light field demos at SIGGRAPH, we couldn't even fit all those things on the hard drive because each one was, the original data size was like tens of gigabytes. Those things go down to tens of megabytes with this codec, and it could be used for video or stereo 8K videos as well. There's really a whole number of different things you can do with this. We're also open sourcing the container format and the media format itself. There's a lot of benefits to that. We want others to be able to play with this with these things. And if you see some of the work that's been done on VR Desktop, which is a tool that basically loads our stereo cube maps on the DK2, I mean that's an example of somebody taking the media format that we've been sort of working towards and doing interesting stuff with it that we didn't even really sort of touch on ourselves. And then as far as sort of having a zero client player, which is something we really believe in, we're working on a HTML version that can play back this content. We already have the first version of our codec actually decoding in JavaScript. And if you actually are playing with our Octane 3 demo on a web page, then you're using essentially our very first iteration of our web streaming client. And I think that there's definitely a future for web-based VR. I think web VR, when it sort of addresses some of the latency issues and becomes more widespread, could be really compelling. And as far as sort of the ecosystem around our tools and technology on the content creation side, we've been working on supporting things like Nuke. So there's the Nuke plugin.
We've been very busy, and this is actually a fairly old video, but we've also been working on supporting Unreal and Unity. And Unity is not something we've actually publicly announced as a plugin, but we have a dedicated developer on that and on UE4. And both of these tools mean that you can actually do a couple of things. I mean, if you're just doing traditional baking, which people do with both Lightmass and Enlighten, well, Octane will be able to do that, and it'll also be able to bake light fields. Very compelling, and you can then generate and drive content that is either done in Matinee or Unity's animation tools, and sort of leverage this format both locally and in the cloud. And this is an example of just connecting the Unreal Engine viewport to the Octane viewport, and Brigade basically works the same way. For people that have used motion capture, we've been working on a Motion Builder plugin, which is now in beta. And that allows you to basically connect Motion Builder live to Octane and sort of render out anything that you are able to capture. We've also been working towards getting very inexpensive motion capture working with 4Connects, and we're building that into the PC version of our viewer, so that if you happen to have Connects or Lighthouse, you can sort of mix and match that with different devices. We're experimenting with that to sort of get position tracking on the Gear VR. Our experience is the Gear VR is still the highest quality screen that you can actually view VR content on, so we kind of want to see what that looks like with position tracking. And then as far as other plugins go, obviously there's demand for the Adobe Creative Cloud toolset, so Photoshop and After Effects are both actively being developed. In the case of Photoshop, already people use our tools to sort of do relighting with multiple lighting layers additively being combined in Photoshop. And I think that our goal is to actually get it so that when we have Octane and all of our stack integrated as a Photoshop plugin in the version 3 timeframe, you'll be able to do that live, either with an Octane viewport or with light fields that have been pre-rendered, and which of course will mean that you'll have a noise-free 3D scene that you can then compose in Photoshop layers. I think that'll be very compelling. Beyond just simple light fills, we want to be able to do relighting and being able to change the contribution of different objects in light. So we're working on sort of allowing you to paint in 3D space. This is something that we also want to sort of see applied in video as well. This is the very first iteration of our After Effects plugin. And it's worth noting that about half of our plugins are done by third-party developers. And I think once we have Octane 3 at the door, we're going to open up the SDK that these developers have been using to a lot more people, so that there can be a whole bunch of different tools and technologies built around this, especially given that Octane, as you guys are seeing on our website, it actually could be a web service. It doesn't have to necessarily be a library that's embedded into the local viewer. So there's a use case to be made for all sorts of things being created on both the content creation side and on the viewer side with this tool set. And then another important piece, which is live for some viewers and has been used for a number of the entries in our contest with Oculus, has been being able to just offer everything as a service through our website as well. And so there's currently a service built for that called Orc, and it's on orc.oto.com. It's also going to be built into the next release of Octane, right into the tool with all the plugins. So as you're working with Octane inside of any of the tools that you've just seen, you'll be able to just take a snapshot and in seconds have our render cloud be able to render all of the data that you want at any speed that you want if you're willing to pay for it concurrently, and that's very powerful. So I've been using that to render all the 18K content you're seeing either at our booth or I can show you some of this cooler stuff, newer stuff that we have on the Gear VR, and it's also the mechanism by which we know that we're going to be exposing things like Brigade, where we just want to have an engine like that be built on top of the R pipeline that we've been now working on for 4 years. So the way that Orc works is pretty awesome. I mean, essentially every render that you sort of set up on Orc, you can sort of check in on that through the website, and you can change almost every aspect of that render from the website as well. So I've actually started pretty massive renders from my phone and being able, and you can also preview and see the data as it's being rendered from a website as well. So some of the things that we're working on adding are being able to just fully integrate Octane itself into the service, and I think that's going to be compelling when people don't have to have a $1,000 GPU to get really good rendering speeds with Octane. They can just load up our service on the cloud, and I think it's going to be end up being something that we'll offer as a subscription plus usage. I mean, that just makes the most sense. And I think we're looking at having very inexpensive subscriptions for people that are just looking to get into rendering and VR content creation without having an enormous budget or even a powerful machine. I think it's worth showing Brigade briefly, just to, for those that haven't seen it or aren't familiar with it. Brigade is actually, at this point, shares a lot of code with Octane, but it's designed for a very different purpose. I mean, whereas Octane is designed to sort of generate content that is rendered offline and presented as a render, Brigade is designed specifically for real-time use and fully dynamic scenes. And it's to this day, I think it's the fastest ray tracer you can get. With a dynamic scene that you can explode objects. You can have all the tools that you use in traditional rasterization are available in Brigade as a ray tracer. And there's also other things that we have not yet taken from Brigade and applied to Octane. And one of those things is you can have thousands of lights moving around in Brigade, and it renders very quickly without any noise. And that's something that is probably of enormous benefit to Octane as well. And that lighting system you'll see at the very end of this video, where I think there's tons of light in the city scene that should be creating a lot of noise. Remember, this is also something that is being applied for real-time rendering. In this case, we have about 20 nodes on Amazon rendering this scene live. And that is sort of expensive, unless you consider the fact that probably 1 minute of this experience is about what you'd spend to have that, the equivalent thing at GameWorks back in the day when people went to the arcade to have these really nice experiences. So I think that that's also something that we can also reduce by an order of magnitude, with filtering and other tricks. But this is sort of the brute force approaching of just taking Brigade as it is today and seeing, what the cost is or what the in terms of compute to get to noise-free rendering that is, has no compromises. And as far as what we're sort of imagining in the next 2 years, what our focus has been on, there's, and I think I probably need to update this slide a little bit, but there's really 3 or 4 major milestones that are about to sort of hit. And one of these things is going to be when mobile VR really becomes a real platform. And I think that we're waiting on Oculus to sort of release the consumer version of Gear VR, right? That's imminent. That's sort of been hinted at by Carmack for a few months now. And I think you'll also see Android becoming a very serious, Cardboard will become really a big part of Android's operating system in the future. I'm almost sure that that's something that we'll see happen in the next few months. It's certainly going to next year. And, sort of as we get into next year, as I was sort of touching on earlier, you're going to see, PC VR, living room VR really start to materialize, and a whole set of different experiences designed probably for that. And they'll be different in there, at least in the way that the content is being targeted from what you get on mobile. But our goal would be if we can come up with a way where the content and the experiences can sort of be translated nicely between the two, then maybe we've done something of value to the whole ecosystem. And then I think there's another interesting thing that I'm sort of tracking, which is it's just a matter of time before somebody takes a Tegra X1, a really powerful mobile GPU, and just puts that on a really high-end screen. And that hasn't been announced, but somebody's got to be thinking about it, and somebody will do that. And that's going to be for somebody that wants to have an experience that's close to what you get with PC VR, but more, but with the benefits of untethered portability. And I think that'll happen next year. I'm sort of tracking, a number of companies are looking at doing that, but I don't think we've sort of heard anything from the big players. But you can sort of imagine that being, very, very possible next year, especially when you look at things like Tango, which actually do have position tracking, and we've gotten that working with our light field viewer. You can imagine something being built out of that with a baked-in VR viewer. And I think that's something that is going to be a very compelling platform for content. As we sort of go, into 1 to 2 years out, then AR becomes something that we can actually start thinking about more seriously. And I also think there's going to be a complete convergence between VR and AR. And the question is whether or not you get a pair of glasses that are able to sort of put blinders on you so you go into VR mode, or whether VR will have, as we think of it today, will have a pass-through camera system that is so good that you just have everything, all the benefits of AR are sort of there. And when they're both the size of sunglasses, does it really matter? As long as they both, when they converge and look the same. If I had to take a bet, though, I would say that the more interesting iteration out of those two would be to have the camera pass-through system there, because there are things that you could then project back into the eyes that are captured or translated before they get into your, get sent into your eyes. And that could be, for example, giving the ability to sort of have X-ray vision, right? Where if you have a room modeled, you can see through things. And I think that also that's how you're going to get 1 billion AR devices out in the market, not necessarily by building a cheap pair of Magic Leap glasses, but by actually figuring out maybe having a light field camera system in the front of a cheap device. It could be 4 lenses, 4 cameras, and sort of doing the reprojection that you sort of see already embodied a little bit on the Gear VR now with the pass-through camera system. And then the market itself is something that we also are looking at. There's obviously a huge market ahead of us. This is obviously an optimistic view of it, but even if it's up a factor of 10, I think there's an enormous potential in the market space for content. And as a company, Otoy's focused probably on a good third of these different spaces. And I do think that VR and AR will be one just one and the same by the time by the time we get to 2020. In any case. So that's pretty much it as far as sort of giving you guys an update on where we're at. Are there any questions or anything I can sort of elucidate or answer more directly. Thank you. If you guys want to see some of our latest samples in the Gear VR, Jackie in the back has some cool content that we can share with you guys, and feel free to ask me anything as well. I'm here probably for another hour or two. Awesome. Oh, question. So it's DCT-based compression. It's not JPEG. We created it ourselves, and we've been, this codec, or the earlier version of it's been out since 2008. We've been using it for doing high-end streaming or high-speed streaming. And the second version of that codec, which we started on in 2010 and we've now finished, it does a couple of things. One, it has much higher quality than H.264 in certain use cases. Like, for example, high-end, a Blu-ray stream or disc could be compressed about half, so that it matches HEVC. It also has high precision, so you can take FP32 HDR or depth maps and just compress those, and it also has complete multidimensional encoding, so you can encode light fields, you can encode reflectance fields, pretty much anything, and it's very inexpensive. I mean, it's 1/25th the compute cost or steps at HEVC. So it's easy for us to write decoders on ARM Neon and things like that, and it also doesn't have any of the. We carefully designed it so it doesn't step on any of the HEVC patents. If we were to use those patents, we could probably make the codec even better, but we're not. And I don't think that need is there. It's an option. I mean, you also can not use the compression, and things are bigger, but we designed it because we felt there was a need for that. Yes, there is a huge amount of repetition, and that's something that obviously can be. Well, here's the thing, though. I mean, even H.264 and even HEVC, they failed to deliver a really good. I mean, the benefit of both of those codecs would be ostensibly that you have hardware decoding on mobile, but I don't know of any hardware that does stereo decoding for H.264 properly. I mean, I think when Google does their MVC stuff for their viewer, like, it's being decoded in software. So at that point, like, we can do that better ourselves, and we will. And then the HEVC stuff, besides the 5% thing, which is a huge blow to anyone looking to adopt it, there's also the fact that their multi-view stuff is still a year away from being really formalized, and I think that means it's even further out from being put into any hardware. So there's an opportunity for us to do stuff, even if it's just stereo encoding, much less light fields, to apply that into the codec that we have now, and that's kind of what our plan is. Question? Sorry, which kind of video? For those 18K things, or for light fields, or both? Well, I mean, I'll start with, and we're talking about two different use cases. I mean, one is, today on the Gear VR, yes, those 18K videos are blow out any hope of us doing that, especially the way we're doing it with a full 18K frame on the hardware decoder. So, the hardware decoder actually physically doesn't process anything more than 2160 vertical. So unless you decode each phase one at a time, which means you're limited, I mean, you're going to go from 60 to 20. You kind of need to do this. What we're just using OpenGL shaders to decode these frames and blast them back. And we can stream that from the local storage. I mean, right now in the demos we have, we're just blasting it up, putting it all in memory. You can actually scrub through it really quickly, which is awesome. But there's no reason why we couldn't stream it. And those videos are large. On the other hand, they're not that much larger than than H.264 videos, MP4s. So we had a 4K clip that was 32 megabytes. That was, and the same exact clip at 18K is 300 and something megabytes. So it's 10x, but it's also 10 times the pixels. And it's, despite the fact that it's basically very simple predictive deltas between the frames to just, because it's basically texture compression, it works. And I think that there's a lot of compelling use cases to be made with that. And I think the harder part of that problem is, how do you render 18K videos? And I think the cloud is the answer to that. I mean, we're working steadily on getting the cost down. I mean, the time is already whatever you want. If you want the 6-second clip we did, which was, you have to think about that, it's 30 megapixels per frame at 60 hertz. And we render that in a few hours, and the clip you'll see on there is pretty awesome. So I think that there's, that's kind of been sorted out. And then we'll apply that to light fields as well. Light field rendering, we have more options on the PC, which is kind of where we think there's going to be the very first application of this, of the viewer. But as I was alluding to before, I think that when you get a Tegra, we do have our light field viewer also running on Project Tango. So if somebody builds a mobile VR device out of Tegra parts, then we can potentially get that working as well. And there, I think that, yes, video becomes a harder problem, but then if we also have our full decoder and we're not trying to do some sort of, hack with texture compression, we can apply video decoding in temporally for light field video, and it's going to be fine. And I think that's where we see a benefit to the codec that we built. I will say that while we do have a single cubic meter of a light field frame down at 40 megabytes, when you start thinking about having a room-sized light field, even with that compression, that's 5 meters by 5 meters, multiply it by 125, and then you start getting into, oh wow, now this thing is 4 gigabytes again instead of 40 megabytes. And that's where we have to just figure out how to do light field streaming. And I think that's one of the reasons why we've been working on our own codec, because at least there, we can stop doing things like what we're doing on our website now, where we're streaming Octane and it's just grabbing the back buffer. We'll actually just take chunks of the light field from the server, send it down, and then update that. And you'll also get rid of the latency problem by doing that, because we're just sending that down in world space, right? So as you move around, or look around, it'll basically reproject locally, and it's the perfect way of sort of streaming down content. And we want to have that up and running in the next 6 to 9 months, along with more complex reflectance fields and even the ability to sort of move objects around in a scene, which we can then handle with very simple ray tracing locally with some iteration of Brigade that's maybe adapted to PCs. So that's kind of what we're thinking about as we get into next year. Any other questions? Thank you very much. Oh, another question. For which software? Well, the renderer, you can actually download it. We actually, to this last 4 years, you can actually download the tool yourself and render it on up to 12 GPUs with network rendering. So that's something we offer today, and it's only very, very recently that we've added the cloud service. In fact, that hasn't even launched yet. So yes, you can always download Octane, and we'll probably add a subscription service. You can just rent it for $10 to $20 a month, and then you can use it to render what you want locally. If you saw with the light field capture, you can spin a camera around in a circle. You can also render in a circle and just send the same data to the cloud, and we'll process that and turn it into a light field. That's something that we're building in so that you can use any kind of rendering tool or any capture tool, and we can figure out how to build a light field out of that. But there's today, we currently have a version that is only on your local machine. So the cloud service is something that we think we're rolling it out this year, but next year it's going to be of greater value, and it's an augmentation of what you can do today on your own machine. And there are benefits to having thousands of GPUs at your disposal on demand. You can't map the same sort of problems to a dozen or even 100 GPUs that you can when you have that kind of compute power readily available. But if you want to do things locally, we're not going to get rid of the tools that we sell today, so both options will be available. The light field, so there's certain things that just don't make a lot of sense to do on one GPU. I mean, the way that we're doing efficient light field rendering is spreading that across hundreds of GPUs, because we can just split the problem up spatially. It doesn't mean that you can't render that light field locally. It's just harder and it's more work. And I think what we'll end up doing is we have a Lua script, for example, that can be used to generate and we have many different ways of generating those light fields. We'll probably put out a script that allows you, if you want to do it all locally, and it'll basically allow you to generate enough views to send to the cloud service to actually stitch together into a light field. And if it makes sense, we may make all those tools offline. We haven't really thought that through yet. I mean, right now, our goal is to get this thing in a form that is usable and practical for as many people as possible. But I think that there's many different ways of skinning that cat. Certainly, when we provide a mechanism for capturing real-world data from a camera, then that's something that you can apply to any render, including ours. I think ours is going to be very suitable for that. So there will be tools that allow you to attack the problem from both directions. The cloud is, again, something that we think is probably important, even for us internally with our budgets. I use that to at this point, render almost everything that we're doing that matters. And we have a few hundred GPUs in our office, and that's nothing compared to what we get on Org. I'm sorry? Well, mainly through Paul. We've been working on many different iterations of that, from spinning mirrors to the stuff that was just more recently showed at SIGGRAPH with Pico projectors. And it's something that I think is going to have a lot of value as you get into bringing the displays much closer to people's eyes in an HMD. And I really want to see that happen. I mean, I think all the content we're creating as light fields, really you're missing out on a huge amount of what it could be experienced as, because we do have the ability to blast those rays, 8 different rays into your pupil, so you could get proper convergence. I want to see that happen, and I want to see that happen in a near-field display. I think it will, as displays get better, as people come up with interesting approaches to that, like what Stanford and NVIDIA were talking about recently at SIGGRAPH. So I do think that I'm a huge fan of Paul's approach, which is to build that at room size with these things that are just free-form wall-sized light field displays. But I think there's also a huge benefit to getting it in HMDs, and it's certainly Magic Leap. I think the magic there is that they have that working today, and I think that's why they've driven a lot of excitement around what they're doing. My guess is that kind of is what they had from the get-go to sort of get sort of the momentum around their work. So I expect that to be the norm. I mean, you have people at Oculus, NVIDIA, obviously Magic Leap working on this problem to get light field displays in an HMD, and I'm sure it'll happen in the next few years. I just have to imagine it will. If nobody else will do it, I think Magic Leap's going to come to market with that in that time frame. Great. Next, yeah.